Okay, so at the top I have that function f at x equals x to the fifth minus 9x to the fourth. We want to find the roots of that. And that's a tough one because we have to determine the multiplicity of some of the roots. And you can do that graphically. And I'm going to use Google to do that. So let's take a look at the graph first so we kind of know what we're doing. So I'm going to pull up Google. And I've already typed it in as a function of f at x. And there it is, caret for exponent, just right into Google search. And here's the equation. The problem is, if you notice my y-axis, that's pretty crazy numbers. So I'm going to adjust that so that we can get kind of zoomed in. There we go. I'm just zooming, scrolling with my mouse wheel. So I want to make that a normal set of numbers so we can get at the x-intercepts. Oh, other way. Yep, that way. Oh, there I'm going by 100, so now we're getting a little closer. And we'll just keep zooming in. And you'll notice that it does a little kind of zigzag and then goes back down. If you watch that, so that means I have multiple roots for this. And now I'm going to adjust the vertical a little bit. Yeah. So that we can get right at the number. And so it looks like the number 1 is our root. So 0 and 1. And notice how it kind of flattens out at 1 and then goes back up. That tells me that there are 3 roots there at 1. So it happens 3 times. And so let me kind of go through that progression with you so you can see that. So let's say you had x squared plus 2x plus 1. We'll go to an easier one. We'll come back to this. We'll save that for later. But if you had x squared plus 2x plus 1, that factors to x plus 1 squared. Okay, that means I should have a root or 0 of negative 1, and it has a multiplicity of 2. So it occurs twice. So it should only touch the x-axis at one spot. So let's go back to Google here. And we'll bring up that same graph, but I'll just change it. And instead of that big long thing, we'll just type in x squared. Well, I'm going to type it in its factored form. So it's x plus 2, or maybe it's 1, I don't remember now. X plus 1 squared. And then caret squared, hit enter. And there's what the graph looks like, right there. And notice it just comes down here and touches the graph in one spot. So let me kind of zoom in. Oops, I'm zooming out. Let me zoom into that one spot. Yeah, there it is. So it just touches at negative 1 and then goes back up. So that tells me that the multiplicity is 2. Anytime it touches at that one place and then bounces back off the graph, I have 2 roots at that same place. And so you can write it as x plus 1 and x plus 1. So here's another one. X squared minus 8x plus 16. That would also have 2, and it'd be x minus 4 squared. So just to kind of show that, x minus 4 squared, if we type that in, again I factored it, and if you go ahead and FOIL out x minus 4 times x minus 4, you get that x squared minus 8x plus 16. If you get that, so let me just change that quick to an x minus 4 squared. And there it graphs it for us. And I'll zoom in and notice it just bounces there at that 4. There we go. Then it goes back up. Oh, was it x? It was wrong. I got the wrong thing, don't I? Should have been x minus 4. Sorry. Well, I'll just change that. That won't be any problem. X minus 4. But there again, so it just bounces at positive 4. Let me zoom in there so you can see it. Right there, it bounces off the x-axis and back up. So it's telling me the multiplicity because of that bounce. So let's go to something a little more complicated. Let's say this one is x cubed minus 12x squared plus 48x minus 64. And let's do this so that I can see it and I'm not messing it up too bad. Let me extend the page. I'll show you a couple of them here. So we'll do that green one next. And again, I'm just using Google because that seems like the simplest. Alright, there it is. Now I got them together. And this kind of shows you how to type it in. So x cubed minus 12x squared. I'm just going to select this one and just change it. So plus, it should be 48 minus 64. And graph that. And again, it gives us this really horrible horizontal axis, but we'll zoom in. There we go. And you notice it gives you that zigzag, so it kind of does that whole flattened out area again. Let me get it so you can really see that. Notice it flattens out here at 4 and then goes back up. So that tells me that there are 3 roots. If it would have just went straight through, and I'll show you one that just goes straight through, you would have had 1 root. So I know that this thing factors, since there's 3 roots, I know the linear factor of this is x minus 4 times x minus 4 times x minus 4, or x minus 4 to the 3rd power, because its multiplicity is 4. So I know y equals this. So all of this junk can be written just like that. Y equals x minus 4 to the 3rd. So those are the 3 roots for it, but they're all the same number. So let's try the next one, which is x cubed minus 5x minus 8x plus 48. And maybe you can see a little better what I'm talking about. Let me go up here. X cubed, I'll just change some of the numbers. Minus 5, x squared, minus 8, and then plus 48 at the end. And hopefully I have the right thing. Yeah, that looks right. So if you look, this one swings up here, touches, comes down, touches at 4. Let me zoom in a little bit. And so notice it bounces off at 4. Well, if you remember, that bouncing off means that that's a double root. And then it goes straight through 3 without any curve or zigzag or anything. And so that goes through 1. We have 1 root here that's at -3 and a double root at 4. And so I know that this thing factors to x plus 3 and x minus 4 squared. Okay? So how does that work for our problem? Well, since we knew that that kind of had a zigzag, so back to our original problem, and I'll just bring it up. I know that this factors to x minus 1, because it crossed at 1. If you remember that graph, here was 1. It came up here, flattened out, went through 1, and then went back up instead of going through clean. So I know that's a cubic, so it occurs 3 times. So I know that this function can be simplified to this times something else. So your job is going to be to use synthetic division to find out the rest of the other 2 roots. So here's 1, 2, 3 of your zeros. You need to find 2 more because it's an x to the 5th. That tells you that. And to do that, what you do is use synthetic division. So let's go ahead and find the rest of them. But what you're going to do is use synthetic division 3 times. So let's say we had the number 1. So that is our root, 1. And we got 1, -9, 34, -58, 45, and -13. Okay, so I'm going to divide these out. I just paused just to make sure I didn't got all my numbers right. And I'm going to use synthetic division. So I'm back up here, and I'm taking this whole function divided by one of those factors. I'll do it in a different color. I'm taking this whole function, I'm going to go ahead and divide it by x minus 1. And so that's essentially what I'm doing with synthetic division. So you bring down your first term, which is 9. Or 1, and then you have 1 here, and that's negative 8, and then you have negative 8, and that's 26, and then you have 26 here because you're taking 26 times 1, and then 58 minus 26 is that's negative 32. Then you got negative 32, which is 13, and then you put a 13 here, and this is what we're looking for, is a 0 remainder. That's a good thing. So now what we have, since we started with x to the 5th and we divided by x to the x minus 1, we have x to the 4th minus 8x cubed plus 26x squared minus 32x plus 13. And then we're going to divide that again because the positive 1 occurs 3 times by x minus 1 again. So we're going to divide it again. And so I'm going to get rid of that, because that's what we're doing, but we're going to use synthetic division. So you just use what we have. I'm going to divide it by 1 and do synthetic division again. So 1, that's negative 7, that's negative 7. That's 19, that's 19. Then we got negative 13. We're adding down each time. 13 is negative 13, and again we get a 0, which is excellent. If you don't get 0, you did something wrong, because it should. We know it's a factor. You should have no remainders when you're done. And so then now we're down to x cubed minus 7x squared plus 19x minus 13. And now we're going to divide that one last time by x minus 1. And it should get us down to a quadratic. So again, I'll erase that. So that's what we're doing with synthetic division. So I'm going to divide now by 1. Bring down your first term, which is 1. Then you got negative 6. And then you got negative 6. And then you got 13. And then 13 gives you another remainder of 0. So again, we did it right. That's a good thing. So we're down to, we've divided it 3 times by x minus 1. And we're down to the polynomial x squared minus 6x plus 13. So this new polynomial, to find the rest of the roots, or how it factors, you just plug it into the quadratic formula. So it would be x equals negative b, which would be 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 13, all over 2a, which would be 2 times 1. And then just simplify that out. So x equals 6 plus or minus the square root of 36 minus 52 all over 2. And I'm just simplifying. 6 plus or minus the square root of negative 16 all over 2. And we're down to our 2 roots, which are 6 plus or minus the square root, well, square root of negative 16, sorry, is 4i, and then you divide it by 2. So I have 2 roots here. X could be 3 plus 2i, or x could be 3 minus 2i, and just in my simplification. So I know that whole polynomial that I started with, I think I called it f at x. Yeah, I called it f at x. Could have been factored to x minus 1, x minus 1, x minus 1, times x minus your first complex root, 3 plus 2i, times your second one, x minus 3 minus 2i. And you could simplify those. So essentially we have this. If you simplify some things, x minus 1, this is how it factors. X minus 1 cubed, and then x minus 3 minus 2i, if you distribute the negative through, and x minus 3 plus 2i. And those are the complex conjugates. And there are the linear factors and